Hello, we are Team A from IIIT Hyderabad, and our problem statement is as follows. The two unity gain amplifier op amps are cascaded where the output is taken via the resistor combination as shown. The R2 is equal to 10K and 1K is connected. One terminal is connected to the other terminal of 10K and other to the ground, and the same configuration is followed in the second op amp as well, and the feedback is taken from the output and given back to the input. The circuit diagram is as shown in the figure, and we have realized the same circuit on the board as well. We have taken a dual power supply from the power supply unit, 10 volts power supply, and we have given input from the function generator, a sine wave, and we are seeing the output on the CRO. We have given input to the channel 1 of the CRO, and we have observing the input via channel 2, output on channel 2. So input is the one, the top one is the input and the bottom one is the output. So basically, as we can see, as we are increasing the frequency of the input, if it is increased, we can observe that there is a increase in the amplitude of the second waveform, that means the output. So as we are still increasing the frequencies, the gain goes on increasing. So it goes on increasing up till a certain point, then it falls suddenly. So slowly the gain is increasing. At this point, if we can observe, the gain is almost equal to the input, that means unity gain. Input and output amplitudes are the same. So at this point, both input and output amplitudes are the same, that is unity gain. So slowly, if we are still increasing the frequencies, we can observe that the gain, that means the amplitude drops, that means the gain slowly starts decreasing. The amplitude of the output waveform is dropping slowly. So if we are still increasing the frequencies, the amplitude still drops, still goes on dropping. If we are still increasing the frequencies, so the gain, as we can observe the second waveform, the gain goes on dropping. So it is basically a low pass filter characteristic, and we have taken the readings, that is for different frequencies we have taken the readings of the gain, and we have plotted the waveform practically, and it was in sync with the theoretical waveform. And secondly, we to calculate the phase difference between the input output, basically we need to put the circuit in the XY mode. So basically first it has to be adjusted across the line. So as we can see, you can observe a ellipse waveform slowly. So it's as the frequency is decreasing, it is slowly taking a shape of a circle. At a particular frequency, it takes a shape of a perfect circle, signifying that there is no phase difference. As we can see, this is the circular waveform, and if we are still decreasing the frequency, it takes a positive slope orientation of the ellipse. This is the Lissajous waveform. So from this we have calculated the phase differences, and we have taken the readings and plotted the graph from this. Our next problem statement was to observe the output characteristic if the input is a square waveform. So we'll see now how the output looks like. So our next task was to give input a square waveform with frequency of 100 Hz, and we are supposed to observe the overshoot in the output waveform. So like we have observed the overshoot, as we can see in the below waveform, that is the overshoot. So I am just adjusting the time resolution so that we can observe the overshoot properly. As we can see, the overshoot, the output waveform. So this we are supposed to observe. That's it.